Hello class, welcome to classroom. So this is the second video on the lesson light, reflection and refraction. In the first video, I have given a small introduction on the lesson. Today we will continue further deeper into the lesson. In today's video, we will be talking about reflection of light, the types of mirror, the laws of reflection, and what are real images and virtual images. So let us go to the lesson. So today we'll start our lesson with reflection. So what is reflection of light? So reflection of light, R-E-F-L-E-C-T-I-O-N, reflection of light. What is reflection of light? Now, reflection of light, the phenomenon of bouncing of light when light hits a surface is known as reflection of light. So let us write the definition. The phenomenon of bouncing of light. Alright, the phenomenon of bouncing of light when light hits a surface. Okay, the phenomenon of bouncing of light, we can also write is known as reflection of light. Reflection of light. I will request that you maintain notes because notes are very important for you. After all, you're going to study the notes and write the exam. So please make sure that you grab your notebook, rough notebook, pen, pencil, textbook, and start making notes because it's going to be very much helpful to you, okay, to everyone who is watching. So the phenomenon of bouncing of light is known as reflection of light, okay. Now let us understand in detail, okay. There is so much to understand here, okay. So this is just a definition. There are many more things to understand here, so let us go into detail and understand. So let us draw a diagram here. So let me draw this. So this will be the surface, okay, and then every surface has got two parts, the upper part and the bottom part. So let this be the upper part, okay, this be the bottom part. So I will just draw like this, okay, back side, okay. I meant to say back side, not the bottom part, front side and the back side, okay. So this is the back side, okay. This will be an opaque object, okay. Let this be an opaque object, O-P-A-Q-U-E, okay. Opaque. What is opaque? Opaque means those surfaces which do not allow light to pass through. And in order to study reflection, we need such a surface which do not allow which will not allow light to pass through. Okay, got it? Very soon we will learn about those substances which allow light to pass through, which will be another topic very soon. But here we will learn stepwise. So the first thing that we will learn will be reflection, and in reflection we need such a surface which do not allow light to pass through, and those surfaces are known as opaque surfaces, okay. Opaque surfaces are those surfaces which do not allow light to pass through, okay, whereas transparent surfaces are those surfaces which allow light to pass through, which I might have explained in the first video also. So let this be an opaque surface, okay. This will be the surface, opaque surface, okay. If I ask you a question, this whiteboard, what kind of surface is this? Is it an opaque or a transparent? What will be your answer? Correct. This whiteboard is an opaque surface, okay. It's an opaque surface. So being an opaque surface, it is reflecting light. All right. So we have an opaque surface, okay. Now we will consider, okay, a ray of light. We just need one ray of light. So let this be the ray of light. So let this be the ray of light, okay. Let this be the ray of light coming down from the sun, okay. So the sun produces a lot of rays. We just need one ray. So let us consider this ray. Let this be the ray of light coming down from the sun. This ray has got a name. This is called the incident ray. So capital I, and we can also write small r, okay. Incident ray, okay. IR, okay. IR. So the important terms, let's write here. IR means incident ray. Incident ray, okay, IR is incident ray. Now then this point, okay, where it touches the surface, very important. This point is very important, okay. Let's make it a little bigger, okay, because this point is going to be very important. Now on this very point, okay, on this very point we are going to draw an imaginary line. We are going to draw an imaginary line perpendicular to the surface, okay. So this is the surface, remember, this is the surface, and then we are going to draw a perpendicular line on the surface, okay. So perpendicular means 90 degrees, yes. So we will draw a perpendicular line. So, and it is an imaginary line, so make sure that you draw the line with dotted, it should be a dotted line, okay, not a regular line, okay, because this is imaginary. Now let us name it as N, okay. N stands for normal, so this is N. N is normal, okay, normal. Remember, normal is not an actual line, it is just an imaginary line drawn perpendicular to the surface, and this is useful to study the two angles which we will be discussing very soon. There will be two angles here which we will be discussing, okay. So incident ray, the ray coming from the source of light, then we have an imaginary line which is called the normal, drawn perpendicular to the surface, and then we have the reflected ray, okay. Well, light comes down, strikes the surface, okay, and then after striking the surface it will reflect back, okay. Where will it reflect back? It will reflect back to the surface, okay. It will reflect, it will reflect back to space, so it will reflect back. So we will draw the reflected ray now like this, okay. So this is the reflected ray, so let us name this as reflected ray, so RR, okay. So RR, so capital R, small r, reflected ray. This is the reflected ray. I hope you all are following so far, okay. Now then, between the normal and the incident ray, I repeat, between the normal and the incident ray, that means this region here, you will get an angle. This is called the angle of incidence, okay, angle I. Angle is represented with the symbol I, okay, angle I, which is angle of incidence. All right. Now between the normal and the reflected ray, there will be another angle, this one. This is the angle of refraction, very important. So now we have angle R, this is angle of refraction. All right, so these are some important terms that you have to know when you are studying reflection of light. All right, so incident ray, okay, normal, reflected ray, angle of incidence, angle of refraction. All right, so with this, now we will go to the laws of reflection, okay. So let us go to the laws of reflection, where this knowledge is going to be very much helpful to you. So let me erase this, okay. I hope you have already taken notes. So now we will discuss the laws of reflection. These laws of reflection you have learned in lower classes. I remember in class 7 science, it is there also. So you're in class 10 now, so you have a sound knowledge of these laws, okay. These are not very difficult science, okay. Reflection you have already studied in class 7, 8 also, so you know quite a lot. So let us go to the laws of reflection. LAWS, laws of reflection. How many laws of reflection do we have, class? We have how many? 2, okay. We have 2 laws of reflection. So let us study the 2 laws of reflection together. The first law, the first law says that the angle of incidence is equal to the angle of reflection. Angle of incidence, the angle of incidence is equal to the angle of reflection. So what does it mean? So, well, I have erased the diagram, but then I have to draw another diagram again. So let us draw this diagram. So once again, let me quickly draw this. Okay. So we have this incident ray. This is the point of incidence. We have the normal. Then we have the reflected ray. Okay, this is the incident ray, IR. This is the reflected ray, RR. Okay, so the first law of reflection states that the angle of incidence is equal to the angle of reflection. The angle of incidence, this was the normal. The angle of incidence was here, and the angle of reflection was here. So the first law of reflection says that angle I is equal to angle R. Alright, I hope this is clear. Quite easy, isn't it? Then we go to the second law of reflection, which states that the incident ray, comma, the reflected, let me just write here, ray, the normal to the point of incidence, they all lie on the same plane. Underline the word plane. Okay, I will spend some time explaining what is plane. Now, the second law of reflection is a little difficult compared to the first law of reflection. The first law of reflection is very much easy. The second law of reflection, okay, students find this a little difficult to understand. So, but it's actually easy. Okay, the incident ray, this is the incident ray. The reflected ray, this is the reflected ray. The normal to the point of incidence. Yes, so this point I forgot to label it. Remember class, this is the point of incidence. Okay, please label it, point of incidence. Very important. The point of incidence is very important, and especially to understand the second law of reflection, the point of incidence is very important. So you have to understand this point of incidence. All right, so the point of incidence is very important when it comes to the second law of reflection. I'll tell you why now. So the incident ray, the reflected ray, and the normal to the point of incidence, they all of them, they lie on the same plane. Now, what is this word plane? You just need to understand what is plane. Now, what is a plane? Any flat surface is called a plane. It's called a plane. How simple is that? What is a plane? A plane is any flat surface. Any flat surface is called a plane. So, is this whiteboard a plane? What is the answer? Yes or no? Before you say yes or no, is this a flat surface? Okay, is this a flat surface? Definitely yes, isn't it? This is a flat surface. This is a flat surface. Any flat surface is called a plane. So that makes this whiteboard a plane, isn't it? Yes, so it is a plane. So remember class, any flat surface is called a plane. Examples of plane, the textbook pages are a plane. The notebook is a plane. The cover of the notebook is a plane. The cover of the textbook is a plane. The table is a plane. The bench, the desk, everything is a plane. Okay, so these are all examples of plane. What is a plane? Any flat surface is called a plane. Okay, so now let us understand the second law of reflection. The incident ray, the reflected ray, the normal to the point of incidence, they all lie on the same plane. What does it mean? Now, to let you understand, let me take this exam board. Okay, so this is an exam board. Is this a plane? Definitely yes. If it was not a plane, why would I be even using it? So to demonstrate the second law of reflection, I am going to use this. So this is a exam board. Let me take the back side of it. Now, so this is a plane, okay? This is a plane, and let's keep it like this, parallel to the horizontal. Which is the horizontal? The floor on which I am standing is the horizontal. So this exam board is horizontal to the floor, okay? Now, what if I keep it vertical? How will the orientation be? Yes, this is the position if I have to keep it vertical to the floor, okay? Now, if I ask you, let this marker represent the floor and let this exam board represent the plane. What angle is created between the exam board and the marker? Yes, 90 degrees now. Okay, so if I keep it like this, it's making an angle of 90 degrees with respect to the floor. If I keep it like this, okay, it is parallel. Okay, so to understand the second law, let's keep this plane, this exam board, parallel like this. Okay, now see, if this is the plane, now this is the plane because it's a flat surface, and this is the plane, is not. This is the plane. The opaque surface is the plane. This is the plane. This is the plane. While explaining the second law, while explaining reflection, we were considering a surface. This surface can be this one. Okay, so this is this one. So the surface can be this whiteboard. This exam board. So this is the surface. So light falls on this surface. So let's say this is light coming down from the sun. So light falls on the surface. Yes, now you have heard the sound. So it has made contact with the with the exam board. Okay, in reality, sound will not be produced. Okay, whenever light hits any surface, sound is not produced. This is just for demonstration only. So light strikes down the surface, makes contact with the surface. The point where it makes contact, okay, where does this light land? Does it not land on the plane? Yes, it lands on the plane. So the landing spot, the point where it lands, where will it be found? Will it not be found on the plane? Yes, it will be found on the plane. Then now after landing, light did not come here to stay. Okay, light did not come here to stay. It will go away. It will undergo reflection, so it will reflect away. Now, from which point will it reflect? From which point will it reflect? Will it not reflect out from the point of incidence? Yes, it will reflect out from the point of incidence. So see here, the incident ray, the normal to the point of reflection, the normal to the point of incidence, and the reflected ray. Don't they all meet at this point, which is on the plane? Don't they all meet at this point, which is the point of incidence? And is the point of incidence not on the plane? What is your answer? The answer is yes, isn't it? So the second law of reflection is all about this, which says that the incident ray, the ray coming from the sun, the reflected ray, the ray which gets reflected back to the space, okay, and the normal, even the normal is drawn passing through the point of incidence, and the point of incidence, don't they all lie on the plane? Are they not all found on the same plane? The answer is yes, and this is how you understand the second law of reflection. All right, so the incident ray, the reflected ray, the normal to the point of incidence, they all lie on the same plane. So the most important thing for you to understand was what is a plane. Okay, so a plane is any flat surface. All right, so I hope it is clear. Okay, now we move ahead, we continue with the discussion, and then now we will discuss the types of mirror. Okay, so please keep writing the notes. You can always pause the video, okay, and then write the notes. I will strictly encourage that you maintain notes, because you have to study the notes. You have to have a good amount of notes. If you want to score good marks, you have to have good notes. Okay, one important thing here. While studying the reflection of light, which part or which nature of light is considered? The answer is the particle nature of light is considered. Okay, so to study reflection of light, we assume that light is made up of, well, we don't assume, but it's been proved that light has got a dual nature. Light has got two nature. One is the wave nature and the other is the particle nature. So to understand phenomena like reflection, okay, we consider the particle nature of light. Okay, and light is the particles which make up light are known as photons. All right, so now let's continue with the topic. The next discussion will be types of mirror. So let us learn about the different types of mirror. Types of mirror. Let's say mirrors, plural. So in your syllabus, you will be studying two types of mirrors. We have the plane mirror and the spherical mirror. So you will be studying two types of mirror: plane mirror, okay, plane mirror, and the second one, spherical mirror. Spherical mirror. Okay, now what is this plane mirror? Plane mirror. Let us learn something about this plane mirror. What is this plane mirror? Class, the plane mirror is the same mirror where you look into. Okay, whenever you are about to go out, you get dressed up and then you will at least look once to see how you are, isn't it? So where do you look into? You are looking into a plane mirror. Plane mirror is also used as a looking mirror. Okay, so the mirror which is found in the market, okay, which is found in markets around us, they are called plane mirror. Okay, so that is a plane mirror. Now in a plane mirror, let us write the image characteristics here. So this is important because there is a question in your notes where you have to write about the characteristics of image formed by a plane mirror, maybe. So image characteristics, you need to know the image characteristics of a plane mirror. So basically, what do you mean by image characteristics of a plane mirror? It means the properties, the characteristics of an image produced by a plane mirror. So the first thing that you need to know about the image characteristics of a plane mirror is that a plane mirror produces a virtual image. Okay, it produces a virtual image. All right, it produces a virtual image. I will tell you what is virtual image very soon. Then in a plane mirror, the object size, the object height and the image height is same. For example, if I have a mirror here, then my height and the image, okay, which is cast on the mirror, the height of my image on the plane mirror will be exactly same as my own height. Okay, so plane mirror produces same height image, so height of the image in a plane mirror is same. So height of the object is equal to the height of the image. So you can also write as size. Okay, size of image is equal to size of object. So the size of image and the size of the object are same. Okay, the third one, A, B, C. Even the distance between the mirror and the object, okay, is equal to the distance between the mirror and the image. Okay, remember, well, we cannot go inside the mirror, isn't it? We cannot go inside the mirror, but then if we draw the ray diagrams and all that, we come to know that the image distance and the object distance is also same. So the distance of the object and the distance of the image is also same. So we can write object distance is equal to image distance. Okay, so object distance okay, is equal to image distance. Okay, now so these are the image characteristics of a plane mirror, that it produces a virtual image. Okay, the size of the image is equal to the size of the object, and the object distance is equal to the image distance. What this means is that the distance between the mirror and me, which is called the object distance, okay, will be equal to the distance between my image and the mirror. This is called object distance equal to image distance. All right, so these are the three image characteristics of a plane mirror. Now we will continue, okay, to the next type, which is the spherical mirror. So we will discuss about the spherical mirror now. So let me erase this one. Now, when it comes to the spherical mirror, there are two types of spherical mirror. Okay, so we will be studying about the two types of spherical mirror. So let me just erase this one, and we will just focus on the spherical mirror. So now, let me write down spherical mirrors. Spherical mirrors. Under the spherical mirrors, there are two types of spherical mirrors which we will study. One is the concave, the other one is the convex. So concave mirror and convex mirror. So there are two types of mirrors, spherical mirrors, sorry. We have the concave and the convex. Now, what is a concave mirror and what is a convex mirror? A concave mirror is that mirror, okay, which will appear like this, okay. There the reflecting surface will be like this. So if you do your hand like this, okay, like this, okay, then this part, this KV part, okay, this KV part, this is your concave region, okay, this is the concave region. So those mirrors which have the reflecting surface like this, okay, curve, which have a curve reflecting surface are called as concave mirrors, and the other one is a convex mirror. So the convex mirror will be opposite of this one, so it will be like this, okay. So which have a bulgy reflecting surface will be called a convex mirror. So if I do my hands like this, then this part is bulgy, isn't it? Okay, this part is bulgy. So those mirrors whose reflecting surface is bulgy like this is called a convex mirror. On the other hand, those mirrors whose reflecting surface is curved like this is called a concave mirror. Okay, we will draw this also. So concave mirror, I will draw like this, okay, and convex mirror, I will draw like this, okay. So here the reflecting surface is the curved part. So inside this part, okay, this part is a reflecting part, okay. So the non-reflecting part I will show that. So the non-reflecting part I will do like this, okay. This is the non-reflecting part. So this is the non-reflecting part, and this side, okay, this side, the other side, this is the reflecting surface. So this one is the curved reflecting surface. So a concave mirror has a curved reflecting surface. Then convex mirror. So when it comes to a convex mirror, the reflecting surface is the bulgy part, okay, the curved part, the bulgy part, okay, not the curve. The curved one is here, the bulgy part. So this is bulging part, nah? So this side, okay, this side is a reflecting surface. So the non-reflecting side I will show like this, okay. I have told you earlier also that every surface has a front and a back, okay. So this is the back side, this will be considered as a front side, okay. So this is the bulge reflecting surface, nah? So it has got a bulging reflecting surface, okay, bulging, let's just write bulging, bulging reflecting surface. All right, so this is a convex mirror, okay. Spoon, okay, a spoon is a best example which will show you both the concave part and the convex part, okay. So a spoon, I am not very good in drawings, but then let's say this is a spoon. So this part, okay, this part where we are able to scoop the soup, nah? So spoon is like this. So if you if you dip it into solid water, then you will be able to scoop the liquid. So the region where the this curved part, okay, the depression where the water stays, that is the which part? Is it the concave region or the convex? It is definitely the concave. Okay, then this part, okay, this part, the other side, this one, okay, this side, the other side, this will be the convex. Okay, this will be the convex part. So a spoon has got both. It has got the concave part as well as the convex part. Okay, so a spoon is one simple example to see both. So the two types of mirror, concave mirror and convex mirror. All right. Now the next topic will be real image and virtual image. So now let us discuss what is a real image and what is a virtual image. So so the next topic that we will be discussing together will be real image and virtual image. So real image, very important. Real image, this is one very important topic you have to know. And virtual image, virtual image. Virtual image, real image and virtual image. Point number one. A real image is an image which is formed when the reflected rays they meet. Okay, so when the reflected rays meet each other, they form a real image. Okay, so you can write formed. We can also write. Let me give you a good definition. So real image, image formed when the reflected rays meet is called real image. Real image. All right. So image form when the reflected rays meet is called real image. Okay. Then virtual image. Image formed. Image form. Image form when the reflected rays do not actually meet. Image form when the reflected rays do not actually meet but appear to meet are called virtual images. Alright, so image form when the reflected rays do not actually meet but appear to meet are called virtual images. Okay, for example, okay, see here, let me just give you a simple example, okay, of how a real image is formed and how a virtual image is formed. So let me take a concave mirror. So if I draw a concave mirror, okay, very soon we'll be studying about the image formation by concave mirror, but here to give you a clear idea of what is a real image and a virtual image, I will show you. So we draw this line, okay, and we keep an object here. Let's say this is the object. Then the ray goes like this, okay, passes through focus. Let this be focus. Then the ray goes like this, okay, then it goes like this. So see here, I have considered two rays. This is one ray, okay, then this ray goes, touches the mirror here, okay, and then it reflects. So this is the reflected ray and it continues like this. The second ray I'm using this, okay, it goes down, passes through the focus, and then it goes away like this. Okay, now here the two rays they meet. So this is the reflected ray I have to show. Okay, so the reflected ray after touching the mirror this become, or the incident ray become, well, this ray will become the reflected ray. So it goes, and then this point, at this point the two reflected rays, they are meeting. Yes or no? At this point the two reflected rays are meeting. Okay, so an image will be formed here. Okay, so the image will be formed, the image of the object will be formed. So we'll get ourselves something like this. Okay, so this is called a real image. A real image is an image which is formed when the reflected rays meet. When the reflected rays meet, it is called a real image. So here we get ourselves a real image. Okay, then virtual image. A virtual image is formed when the reflected rays do not actually meet but appear to meet. Okay, so for example here, so we'll use again we will use concave mirror. So I'll use a concave mirror, and then let's say, let me keep the object here. Okay, then ray goes parallel, then let's say focus, it passes through focus like this. Then this is the, let this be the center of curvature. Then another ray will pass through the center of curvature, so like this. So again here I'm considering two rays. Okay, one ray, this is one ray. Okay, this is ray number one going, it touches the mirror. After touching the mirror, it will reflect back. So now it's reflecting back. Okay, remember it has touched the mirror here, so it's reflecting back. So it's reflecting back. So this arrow denotes the reflected ray, and it's going away from us. Okay, it's going far away from us. Next, the second ray is this. Okay, this is the second ray. So the ray is produced from here. Okay, it goes to the mirror. Okay, it goes to the mirror, got it, touches the mirror, and then it reflects back. Okay, and then on reflecting back, it passes through the center of curvature. Okay, and then it continues the journey like that. Now if you look at the two reflected rays, see the distance between them is only getting bigger and bigger. It's getting bigger and bigger and bigger and bigger. So they are never gonna meet here. Okay, so the reflected rays, they are not gonna meet here. Okay, they are not meeting. Okay, where the rays do not actually meet. So these rays, they do not actually meet. See, they are never gonna meet. They are gonna get further away, away, away. So they are not gonna meet. Now coming back to this sentence, but appear to meet. So how will they appear to meet? How will they appear to meet? They will appear to meet only when I extend this line. As you can see, okay, it's tapering, isn't it? It's getting smaller and smaller. So they will appear to meet, okay, on extending this line. Okay, so I have to extend this line. So what I do is I just extend this line, okay, dotted line, okay, like this. So on extending, okay, on extending, see, the object is here and the image is from here. On extending, okay, I get the image. Okay, this kind of images are called as virtual images. Okay, okay, so virtual images are this kind of images, whereas real images are those images, okay, formed when the reflected rays meet. When the reflected rays meet, they form a real image, whereas when the reflected rays do not actually meet but appear to meet, because if I view from here, then they appear to meet, isn't it? So such type of images are called virtual images. Okay, that is the first point of difference that you have to know for real image and virtual image. The second point of difference that you have to know is real images are inverted. Okay, the image here is inverted. See, the object is like this, standing upright, whereas the image is like this, isn't it? Downward. So image is inverted. So inverted image. Okay, inverted image. Image is always inverted. Real images, okay, the image is inverted. In terms of mirror, real images are inverted. Okay, then we will write the second point here. When it comes to virtual images, the virtual images are erect. So image is erect. So erect image. Erect image. Alright, so inverted image and erect image. So these are 2 points of difference, okay, which you need to remember to differentiate between real image and virtual images. There is also one more point that I remember now, and that is real images can be cast on a screen. So real images can be cast on a screen. So can be, I have to write image can be cast on a screen. So image can be cast on a screen. Real images can be cast on a screen. Point number 3, virtual images on the other hand cannot be cast on a screen. So image cannot be cast on a screen. So these are the 3 points of difference that you have to know. Okay, so make sure that your understanding of real image and virtual image is very good. So you need to study these 3 points of difference. Okay, and once you are thorough with this, you will have no confusion or understanding real image and virtual image. Okay, this is the criteria. Okay, always judge your answer. If a question is like to decide whether the image is a real image or a virtual image, you have to come to the conclusion using these criteria. Okay, so these 3 criteria are very important for your syllabus, for your lessons. The first point, this point is very important. Okay, in the upcoming videos we'll be doing the ray diagrams and all that. There the first point will be very clear. Okay, there the first point will be very clear because you will be drawing ray diagrams, and when you draw the ray diagrams you will encounter this scenario and you will know, okay, which type of cases will give you virtual images, which type of cases will give you real images. So the first point is very important. Okay, likewise the second point, the third point also is very important. Okay, just to know the differences between real and virtual images, these are important. So we will end the class today on this note. So today we have learned about reflection. What is reflection? Then the laws of reflection, the types of mirror. We have 2 types of mirror, plane and spherical mirror. And then under the spherical mirror we have again 2 types of mirror, concave and convex. Then at last we discussed about real image and virtual image. So I'll see you again in the next class. So thank you all for watching. God bless you all.